name is David McCullough, and I'm assuming everybody knows JB Turner from Front Street Shipyard. Okay, and roughly our format today is that I'm going to go through and talk about the Hope 40, a bit of the design process to date, and what led us to this boat. I'm going to pause for a moment, and then JB is going to talk about Front Street Shipyard, the story behind the yard and their capabilities. And then I'll come back and we'll talk about some of the nitty gritty of tooling and cost of the vessel, or estimated cost of the vessel at this point. The questions that I anticipated, and I'm sure there's many that I haven't, was how much, how fast, and how far. So that being cost, speed, and range. And many of you will have already seen the renderings of the boat before, so those kind of speak for themselves. So it looks like we're stable at a number of participants right now, so we'll go ahead and begin. So bear with me here one second.
Dave, just for a sec, just so for everybody who just joined in, you're all muted, as Dave said earlier, and we'll open it up after the presentation for the questions and through chat.
Okay. So my name is David McCullough, and I have a design, engineering, and brokerage firm in Newport, Rhode Island. I added it up last night and been at this for 18 years as a full-time professional yacht designer. So, and started McCullough Yachts 9 years ago. So over that time, I've participated in 3 America's Cups at various levels. The last one was interesting for me. I actually served as a member of the measurement committee, which gave me full and total access to all of the teams that were in Auckland, New Zealand, including their control systems for their foiling boats. I don't know if everybody got a chance to watch the 36 Cup in New Zealand, but it kind of took technology on several different fronts to a new level. So it was very interesting. I'm not sure on the measurement side if I was the best police agent, but I certainly learned a lot, which was wonderful. My history with Front Street, well, it really began when I was working with JB and Craig Picard. Craig, if you don't know, heads up the design department there at Front Street back in 2005. So it's been a while, a good working relationship with those guys. And that was on a sailing performance cruising catamaran named Mala Conducta that we started working together. My most recent project with them was in May of 2019. We successfully completed a custom aluminum powered catamaran for a corporate client, and some strict non-disclosures with that corporate client, so we can't elaborate too much on what that vessel was, but I can tell you that it was on time, it was on budget, and on weight, and actually exceeded all expectations. So very happy customer at the end of that project. I would be remiss if I didn't mention Alex Donlin. Alex did most of the 3D modeling on the Hope 40 here in my office, and did a wonderful job taking my hand waving and crazy ideas and putting them into a nice wrapping. I'd urge you, if you want to learn more about our business, go to McCulloughYachts.com. We have a lot of interesting and diverse projects up on the website, including 125-foot performance cruising catamarans and some wild projects. So the Hope 40 project for us began with this question, several questions. On your screen right now is a boat called the McCullough 36. And the McCullough 36, built in China, it's a wonderful boat. it is amazing how much they pack into a 36-foot platform. You're essentially looking at down in the hulls, each hull has a queen size berth and its own enclosed head. And then on deck, you've got a bow rider, you've got a nice generous helm station, and a indoor-outdoor galley, and ample seating areas. So I'd urge you, if you ever find one of these at a boat show, even if it's not what you're in the market for that day, step aboard the boat and you'll walk off amazed that there's that much boat there. Our problem with this boat was a subjective one, but it's one we couldn't get away from. It was aesthetic. A lot of these power catamarans come from a very forward-looking mindset. And so the aesthetics, we affectionately refer to them as alien spacecraft. They're forward-looking instead of kind of historic looking at the traditions that many of us love in yachting. The McCullough 36 has actually started to introduce a foil-assisted model. And that introduced, our other questions. And these other questions we kind of cheated on those. It's like when you write down something on a to-do list, but you've already done it, so you can cross it off right away. And that was, can we solve the problems of existing foil systems? What I mean by that is existing foil systems typically have a fixed foil between the hulls. And there's a safety flaw with that. So I had the good fortune or misfortune, depending on how you look at it, I was at the helm of a Corsair 2200, which was an early foil-assisted catamaran. And I was at the helm off the California coast and had a few passengers on board. And I had been sailing cats in the same patch of water within that same week, and had a bit of a brain fart moment where I sent a patch of kelp between the hulls. And so, the kelp instantly hooks onto the foil, disrupts the flow around the foil, and boat drops down. That boat was around, we talk in terms of lift fraction. So lift fraction is the percentage of the weight of the vessel that the foil is supporting. So 100% lift fraction means that you're fully foiling. The boat is out of the water. 50% lift fraction means that you're supporting half the weight of the vessel on the foil at speed. So that boat was probably at around 40% lift fraction when I hit that kelp patch. I lose all that lift, drop off the foil, decelerate. I get thrust into the console. Passengers, get sent forward. Fortunately, nobody was hurt. But it was a bit of an aha moment for me of like, I'm not going to be the last idiot to do this, intentionally or unintentionally. This is a flaw. And boats like the McCullough 36 that have this fixed foil system, their strategy is to make the hull as strong as possible at the foil supports, where this fixed foil intersects the port hull, starboard hull, and the underwing. And so the sequence of failure there is that the foil fails before the boat fails, because these intersection points are happening below or at the waterline. So you have to protect the boat. So you over-engineer that. But that doesn't solve the deceleration issue. You're still kind of accepting the fact that there's a car crash event. So for years since that incident where I hit that kelp off the West Coast, we've been thinking there's got to be a better way. The other question that we had that we already knew the answer to was, can we integrate modern computer control systems into a foil-assisted power catamaran that would really help the ride quality? And at this point, that's low-hanging fruit. the computer control systems are so advanced to the point where they can support fully foiling vessels, that supporting a foil assisted vessel that approaches kind of that 50% lift fraction, that's low hanging fruit. And there's much less stability issues at 50% lift fraction, and those stability issues have less dire consequences when you're not fully foiling. But there is certainly room for improvement on foil assist packages. So, once we identify the problem, then we launch into a study. Some of you may be familiar with this is called the design spiral. So you don't design a vessel in a linear path. You're taking multiple looks at the structure of the boat, at the foil system for the boat, the propulsion system. And it's a bit of an iterative process that you kind of home in on the detailed design that allows you to issue construction drawings to a boatyard like Front Street Shipyard. So, JB and I talked yesterday. This presentation is meant to be very open and honest. So we're not hiding anything here in terms of pricing, of where we're at with the project. This is kind of, how we like to do business, which is just here are the facts. So this design process on the Hope 40 began in earnest on April 2021. That's when I got back from New Zealand from that measurement committee work. One of the things that happened in New Zealand was a Downey style boat was delivered to the viaduct harbor there. And power catamarans are very well accepted within the New Zealand yachting culture because they do a lot of offshore work there. But this Downey style monohull was delivered and craned into the water in the viaduct, and it stopped traffic. People were like, whoa, what is that? Oh, I like the look of that boat. I just kind of stopped on the bridge and listened to people receive, what we would consider a fairly traditional boat here in Newport, Rhode Island. But it was different to them. So that was like, oh man, I wish we could combine, that aesthetic that was well received in New Zealand, has become fairly commonplace here in New England, and of course the functionality of the power cap. So we were motivated after I got back from New Zealand to chase that. To date, we've put approximately 228 design hours into this Hope 40 project, and this has all come out of our research and development budget. I estimate, and we've gotten pretty good at estimating over the years, that to go through this full design spiral and get to the quality of design deliverable that we demand from ourselves, we're looking at 1,715 design hours. So, again, full disclosure, we're about 13% into the process of designing this boat. So when we get to the question phase here, my answer may be to many questions to be determined, because as you can see from these numbers, there's a lot to be determined. So we launched into that study, and then you will have seen that our answer to those questions was the Hope 40. The power catamaran, with live aboard conditions, bundles some interesting ergonomic challenges. So you have to have enough headroom when standing in the hulls to have heads and showers and berths to make that a functional space. Of course, you have an elevated underwing platform, and the Hope 40 actually, I would describe the boat overall without the foil assist as a semi-displacement or semi-foiling hull form. So it actually has quite a bit of underwing clearance. So that's distance from the static water line to the bottom of the underwing or bridge deck between the hulls. So that dictates then, if you're standing on that bridge deck, and you've got the height of humans, how high the cabin house has to be. So you have all these elevations, and they're kind of working against proportions that our eye is trained to receive. So that was our challenge that we didn't know the answer to till we really launched into the 3D model of, could we wrap this thing proportional, again, get the proportions to a place that was pleasing to the eye. And there were a couple breakthroughs there. You'll see that the vessel has what we call a split shear. So that really, once we went from just a single shear to a split shear, that really helped us disguise the freeboard of the hulls. But in the end, we thought we got it as good as we possibly could. We pumped out the early renderings of what we did to get feedback, and overall, we're very pleased with the positive feedback that we've gotten on these proportions. Shown here is the outboard model of the vessel. So we actually developed initially, the concept was inboard diesels driving jet drives, Hamilton jet drives. And that's where the boat on the top here on your screen was developed. And those were those initial renderings that I discussed that we pumped out. And the feedback that we got was, can you do this with outboards? Shown on this outboard version are these very trick, Mercury 600 horsepower V12 Verado outboards. This work was being done shortly after those outboards debuted, and there was hunger based upon our feedback in the marketplace for those outboards. So we kind of put some tumble home on the transom and threw the outboards on. And at this point, that's our primary path forward, is based upon customer feedback or potential customer feedback. More people seem interested in the outboard. I have looked at the possibility of, could you have a single hull mold to do both drivetrain options? And it's interesting. Of course, the center of gravity of the outboard option shifts the overall center of gravity of the vessel aft, but you can play with variables like jack shaft length on the inboard diesel, and you can get them pretty close to the same center of gravity. And then there's also the possibility of putting plants in the mold of the jet drive inboard diesel option to remove some buoyancy aft. So the flotation would be the same. But we're really eyeing center of gravity, because you can imagine with a foil assisted boat, center of gravity is critical. So you want the foil to be incrementally forward of the center of gravity. So you're inducing a bow up trim, and you can't. You have to know where the center of gravity of your vessel is if you're committing to put a foil underneath it. But for now, the Mercury outboard model seems to be our preferred model. An update. Some of you may have poked around our website or Front Street's website and looked at specifics of this boat. We're getting a little bit deeper into the weight study since some of those numbers were pushed out. And the vessel's now sitting around a full load displacement of 22,000 pounds. We previously had it about 18,000 pounds. And the boat is not fully engineered yet. I talk about that design spiral, and we're only 13% of the way in there yet. But, we're more comfortable that we can wrap a robust fiberglass structure into the boat at that at that 22,000 pound number with limited carbon reinforcements. And this would be infused laminates, some cord, some monolithic, and definitely the 22,000 seems like a more obtainable number. But given that that weight, I talked about when we began this discussion, how fast is the boat going to go? So this is 3 different engine options, because I started looking at speed and range with the Mercury 600 horsepower outboards. So 2 of those, 1,200 horsepower total, and actually got a little spooked at how fast the boat was going, even at the 22,000 pound number. In my mind, this was kind of a 40 knot boat. I did a lot of time chasing America's Cup boats around New Zealand at 40 to 45 knots on a power catamaran called Catalyst 45. And there's a big difference in terms of accelerations and passenger comfort between going 40 knots through waveforms and 50 knots. So you can see, here on the x-axis, that's vessel weight. So those far left dots are those 18,000 pound that displacement that it looks like we could achieve, but we would have to be very aggressive in terms of our laminate engineering, and that would drive production cost up. And then that 22,000 pound number that we ended up settling on. So even at that 22,000 pound number, the 040 with those 2 600 horsepower outboards, is just shy of 45 knots of top speed, and that's fully loaded. So that's full tankage, provisions, passengers. So that's plenty fast, given kind of the family fun target for the Hope 40. I also started to look at, they offer a 500 horsepower Mercury outboard. That's also the V12 block, more of a commercial rating. Very interesting engine for this application. Longer duty cycle, would actually be an excellent fit for the boat, still above 40 knots of top speed at that 22,000 pounds of displacement. And then, we'll talk about cost here at the end, but there is an incentive, as always, to get cost out of the boat. And stepping down to the 2 by 400 horsepower outboards, 800 horsepower total, it's still cranking. It was a 37 knot top speed there. So that's still, gets you here from Newport, Rhode Island to Cutty-Hunk Island pretty quickly. So that's kind of the how fast, and those numbers are assuming a 50% lift fraction on the foil. Interestingly, those are different foils. So you would not put the same foil on the 2 by 600 horsepower boat that you would put on the 2 by 400 horsepower boat, because lift force from the foil changes with the square of velocity. So the faster you go, you're gaining lift at a rate of a square. So anyway, you would have more foil area on the 800 horsepower boat than you would the 1,200 horsepower boat. But that's also, the foil is a nice place to tune that. So this range example was run with the 2 by 600 horsepower Mercury's 22,000 pounds of displacement, 500 gallons of tankage, cruising at 37 knots. So that gave us a range of 293 miles or 255 nautical miles. That's a run time of 6.9 hours. So that's a full day on the water. And that's using 450 gallons. I never like to do range calculations where you're leaving your tankage empty. So that's 50 gallons of reserve there. So we given our weight study at this point, think that vessel can support that level of tankage. Oops. So to pause for a moment, we'll talk about the general arrangement of the vessel. And this is really where you may have noticed on the specifics, the overall you have 16.5 feet of beam. So to compare this to a 43-foot monohull of a similar style is really a bit of apples and oranges, because the amount of living volume that you have on the Ho 40 is it's closer to a 60-foot monohull or 65-foot monohull in terms of interior volume. So you're getting quite a bit of boat here. The arrangement that we're on right now, I've lost track of how many iterations we've been through, has your outdoor settee area with drink refrigerator, easy access there in the back of the bus. It's got a nice settee with a table here. This table we'll talk about shortly. It is getting close to where we want to put the foil, which is very nice in terms of access to the foiling equipment. Indoor, so then this bulkhead here, that's the cabin back bulkhead. So this is open air space aft, and then enclosed space here by the helm, this interior settee, and efficient galley area to starboard there. We are looking at induction cooktops with enough battery to back up the induction cooktop so that we don't have to carry any propane on board. Into the port hull is the master cabin hull. So queen size berth forward, actually a couple different storage areas, a place to sit, maybe even have a fold out table if you needed to seek out quiet space to work on your laptop. And then a full head with its own enclosed shower. So no wet head on the port side of the boat. Spaces have enough doorways to allow for privacy. So if somebody wanted to use that head in the port hull, they wouldn't disturb who was sleeping in that forward cabin. On the starboard side, you come down this companionway. Underneath the galley is a volume that can be used for additional freezer and fridge storage. Forward is a bit of a bunk room. This could also be call it a double size or a full size berth. But this particular arrangement was appealing to me. I have a family of 4 with 2 young boys. So this would be an excellent layout for a family of 4. And then a head forward. That head forward is a wet head. If it was my boat, I would actually not even have a wet head there. I would just keep that as a simple toilet and sink. And then if somebody wanted to take a shower in the boat, go use the dedicated shower space on the port hull. But again, that's kind of taking a family look at the vessel rather than like a hosting guest. If you're a couple hosting another couple, maybe an arrangement that has a full-size bed and that wet head would make more sense. So there's some flexibility here in terms of changes that could be made without drastically affecting the center of gravity of the vessel. But it's a lot of boat. So talking about this foil system, this retractable foil system, and this is a system that does not exist in the universe right now, but I'm convinced for the safety reasons I discussed that it really needs to. This is an early kind of a part layout of the system that we snapped some renderings of. And you can see this kind of awkward view here is is a slice to the boat on center line, or just to port of center line. And it shows in this particular arrangement, the whole foil system was housed subsole in the salon. So the boat has a bit of a double floor on the underwing, which is great for systems access. And this foil control system was in that double floor. We since have moved this whole foiling system up into that salon table region. So that gets it further elevated and allows much easier access to these components. So speaking of components, this is again at a very high level of how this system works, is we're using an adjustable angle of attack on this foil. So the foil pivots up within the underwing, within the bridge deck. As it moves through the water, of course, the foil is trying to be pushed aft. Its movement aft is restricted by a tension line that runs to a double locking linear actuator. And for those that may not be familiar with this type of linear actuator, these are high load linear actuators. They're actually used on a series of electric forklifts. So it's electric forklift equipment. We've purposely not used hydraulics. Entering or using hydraulics for the system introduces a level of complexity that we think we can avoid with the linear actuators. This overall system is designed to be as simple as possible. We're introducing complexity with this variable angle of attack and pivoting foil, but at the same time, this is you'll see it's a very sailor-driven system. Sailors think in terms of tension members, and this follows that ethos. So on the trailing edge of the foil strut is a bungee or a tension device. So the foil is always held in space by these two competing forces. Forward you have a tension line, and then aft you have this spring-loaded tension line. But then you can adjust the angle of attack by adjusting the throw on the linear actuator. So I posed that safety issue of you send kelp through between the hulls and it hits the foil at speed. We've established that now you're traveling at 40 knots plus. What happens? And that's where we have a shear pin. So this is actually pretty straightforward double shear engineering math, where we can use a low-cost replaceable shear pin, and that fails at a specific impact load. And when that happens, the bungee cord is designed to have enough tension in it that the entire foil swings up very quickly and hits what we call a bang plate, which is actually it's a foam housing that the trailing edge of the foil finds itself in and cuts into that foam housing. So it dissipates its energy over a distance. Then to reset, so you have now survived the car crash. It has to retract very quickly because you can imagine the foil is trying to induce a negative angle of attack as it's retracting. So the retraction force is not insignificant, but it bangs up, and you hear this happen. You feel the deceleration of the boat, but it's a much lower magnitude event than the car crash that I described with the fixed foil system. We're also not having to over-engineer the hull structure where the foil intersects the hulls or where it intersects the underwing, because we're not worried about the foil ripping out those segments of hull. It's designed to pivot out of the way. It does require some features in the hull. There's basically a step or a chine that happens just forward of the foil swing path. It affects the hull shape, but it gives that foil a path to move through. So that's our rough idea in a nutshell. Okay, so that's enough of the technical bits. I'm going to stop sharing my screen now. JB's going to tell you about this little slice of heaven that's on my screen now, Front Street Shipyard, and hopefully he'll convey, why I think this is the perfect fit for this project. And I'll turn this over to you now, JB.
All right. Thank you very much, David. That was excellent. All the details of trying to get everything involved and why and how this all came to fruition as far as we've gotten so far. Many of you do, or many may not know of Front Street Shipyard, but we're a yard up on the coast of Maine at the end of Penobscot Bay. And we built the yard back in 2011. I have 4 other great partners. That's what it looked like when we started, and come a long way, baby. So we have about 100 employees that work on all the trades at the yard, and we try to make sure that we control the project, and that's why we have all the employees in-house, so that we understand what the budget's going to be, what the time frame needs to be, and then we have some amount of control over the whole project, and can set the priorities as we need to set them. But the boatyard or the shipyard is essentially laid out in 2 different sides. The side that's closest to you from the travel lifts going north is the service side, where we take care of all of our many service yard customers that we store in heated storage and cold storage for the winter, and also have all the slips available for the summer, and the slips that are out in the harbor you see there, as well as moorings further out. And then the other side of the yard really is designed with the 2 big buildings for refit or new construction projects that we have both going on at this time. So we have a big lift, which is 440 metric tons, and we have a smaller lift, which is 165 metric tons, 160 metric tons, which is also pretty big. That we move boats in and out of the shops that you see in front of you. This is a drone footage what we call Building 5, one of the 2 bays in 5, and then we have mezzanines where we set up all of our workshops on. We have overhead cranes and filtration systems and everything that makes life better for everybody working in the shops, and try and make it as efficient as possible throughout. And then we're now flying into what we called Building 6, which is our newest building, and it was built specifically to be able to drive the 440-ton machine with full load into it. So we have, for example, currently in that shop, we have a 136-foot Yongert, which is a steel hull sailboat that we're doing a massive refit on, from all systems, networking, joinery work, paint work, steel, and corrosion work, everything throughout the boat, masts, every part of it. So we get deeply involved in all these different types of boats. We feel very comfortable, most comfortable when our new builds, when we're working with fiberglass or any kind of composite construction, whether it's carbon, Kevlar, e-glass, whatever. As David mentioned, we did a project with him on aluminum, which is a little rare for us, but we do have a full fabrication shop where we build many different parts and pieces out of different metals. But rarely do we build an entire hull out of different metals. And that's really a function of the size of the fabrication shop and our desire to make it bigger, or not in that case. But we are fully capable of working in all mediums, and we also have one of the largest water jet 5-axis machines in the country that is currently flat out cutting all different types of materials, from composites to stone to steel, stainless steel, et cetera, et cetera. So again, we try to cover all the bases when it comes to building technology, and working with designers such as David have been fantastic. One of my favorites, David McCullough stories, and he probably doesn't even remember this conversation. We were building some custom carbon fiber dagger boards for one of the gunboat 66s, and he designed these boxes that the boat was going to sit on while we were working on the building and setting up the new daggerboard system. And we built the dock boxes just as he had drawn. We put them down into the shop, and we picked the boat up to put it into the boxes. And everybody's like, "Why are they so tall?" So I called up David. I said, just out of curiosity, why are these things like 6 feet off the ground? He says, "Well, JB, I'm trying to engineer you for success." I was like, "Okay." He says, "Now you're able to stand under the boat and work on it perfectly. You can run the daggerboard up and down without having to lift and drop the boat." I was like, there you go. Engineering for success. So I can attest to the fact that he thinks every project through all the way, and it's a great person to work with, and we always look forward to working with David. Part of our facility we also have, which is offsite, is up in Bucksport, which is about a 25-minute drive. Is a facility that we run that runs more towards production boat building. We have built approximately 50 lobster boats up there of different sizes. We're building prototype vessels. We've done a 26-foot, sort of like a hydrofoiling power cat, if you will. We've done different boats, one-offs for different people. We're also doing a large run now of ribcraft for the Navy. So we do a lot of different things up there. Currently, they're doing all infusion. Previously, they've done hand laid. We've done pre-preg work, so it's a mixed bag, but that keeps things interesting. And we do a lot of custom yacht work, as I mentioned earlier, on all different materials, all different woods, this is a picture of Baroda, which is a steel fed ship that we did a complete refit on a couple of years ago, and came out well, and we're still very good friends with the owner, and actually we're on their newest fed ship recently. So this is a picture of some of our different mediums we've been working with, loading up an infusion right here, as this picture shows, but we're really comfortable with anything in the composite world, and I'm very happy to dig as deep as we need to dig, or just be simple and straightforward if need be. This is a picture of a boat that we actually launched for the second and hopefully final time yesterday. It's a Sea Raymond Hunt design 41-footer that is full custom boat, one-off molds. All the molds are gone now, so if you want another one, we start all over again. But she runs and is as designed, weighed as designed, and was on target for speeds and budget and all that. So happy owners, and we'll be delivering her to Sag Harbor in approximately 1 month from next Monday. So we'll be doing sea trials shortly. So that's a little bit about Front Street, and I think we'll turn it back over to David for more information, and we'll kind of go back and forth a little bit now, I think, as we move forward through the presentation.
Okay. So I'm going to go through some of the build process now, and then that highly anticipated pricing information, at least of what we estimate at this point. Before we move on past Front Street, I want to make a comment that, from the design office side, I often view these projects as how do I mitigate risk? Risk for the client, certainly first, and then risk also for a design office. And I see Front Street as a very low risk option for multiple reasons. What JB was talking about, where they have all trades under one roof, is that they take responsibility for the success of the vessel. So there's no pointing fingers from contractor to contractor of, that's the composite guy's fault, or that's the electrician's fault. Everybody ends up in JB's office. So we like that. We like that accountability. The other is location. You can certainly chase lower labor rates internationally. But given our current global political climate, post-COVID universe, whatever you want to call it, Front Street feels like a very safe option of if you're going to have what we're going to talk about, a multi-million-dollar asset sitting somewhere, this is a good, safe place to have that. And not only a good place to make an investment like that, a good place to visit it. So the type of customer experience that Front Street excels at, that we really enjoy within our design office, is we really get to know our owners. And we urge them, visit the build many times during construction. Start to form that relationship with the vessel. If you look at these things from a purely analytical, I need a vessel to get me from A to B outlook, these don't make sense. These are emotional exercises. We form these emotional connections with these vessels, and they're lovely vessels that we have a pride of ownership with. So we encourage our owners to start that relationship during the process, whether that be, coming into our design office in Newport, we put you in the virtual reality goggles and you walk around the boat, which is a lot of fun, or, visiting, being there for the day that the portions of the hull pop out of the mold. It's all part of the experience. Okay, speaking of molds, the build strategy for these catamarans is a little bit different than people might be used to on monohulls, and they allow some unique opportunities. So what's outlined here are multiple pieces of the puzzle that come together. The kind of burgundy mold is what we call the sled. So this contains the hull shape, the lower hull shape past center line on each hull, and the underwing surface. And that's a single infused laminated piece, a big piece. And once it pops off its female mold, before it pops off its female mold, the internal structure is put into the boat. So here that's shown as these green bulkheads and longitudinal members. So that, of course, holds the shape of that sled lamination in place as it's craned out of the mold. Then once it's craned out of the mold, it's put onto chocks, and it's a very interesting object to work with at that point. You can start to flow the propulsion system in. If you were doing inboard diesels, those engine beds and that entire mechanical system can be installed. You put the rest of the structure in place. You can start to put the interior in. You put plumbing systems in, electrical, and everybody has access from all sides. You're not restricted from coming in and out of one narrow companionway. You can imagine the gangplanks going on to this sled, and the trades aren't stepping on each other and so it really helps with efficiency. So then once you get the boat basically as far as you can possibly get it while it's in its sled configuration with its internal structure, then you put the outboard sides on. And the outboard sides are pretty simple pieces of kit that are bonded port and starboard. And then after the port and starboard sides are on, the cabin house, which is a single piece infusion, maybe with a secondary bonded bill over top of the windscreen, that goes onto the boat. And then finally, in gray there is the transom shape, which contains its compound curves, and that's a separate molded piece. So if you add that up, you've got the burgundy sled, port and starboard, outboard hulls, that orange cabin house, and the gray transom. That's 5 molds. So we reached out to Symmetrics here in Bristol and asked for a ballpark bid given the surface areas for those 5 molds. And this is where we get to the pricing. So Symmetrics I said, okay, for those 5 molds, for the male plugs and the female tools that come off them, production tooling, you're looking at $600,000 or $600,100. We estimate at this point, given the information in terms of systems, surface areas, composites that we have compiled so far, that the ballpark price from Front Street Shipyard, not including that tooling cost, is $2.7 million. And that price is our honest attempt. The approach that JB and I are taking on this boat is what we call bad news up front, where we're not going to say that we can do this boat for $2 million and then you get into it and it's going to pop up at 2.7. So that again, and I'll preface this a few times, we're 13% into the design process, right? So at this point, that's our price estimate of the boat. So given that tooling cost, that female production tooling cost, there is a high incentive to share that tooling cost. So what I mean by that is if 6 owners came forward, then the tooling cost to each of those owners would be $100,000. And then they would essentially, that group of 6 would own the tool. So, if it could be nursed to future production, then they would get paid for use of that tooling. As is traditional on projects like this, of course, build slots are awarded on a first come, first served basis. So that being said, let me switch gears and we'll pull open the chat window and see if anybody has questions. If you haven't typed a question into the chat window, I encourage you to do so. Either that or you can raise your hand and we can unmute you if you'd rather speak your question. Okay, so Greg asked, what's the intended foil construction material? And that's aluminum. JB didn't touch on the fact that they have this pretty incredible water jet cut machine there at Front Street. So this is a aluminum fabrication that we would do on site at Front Street, and we don't have to outsource it. It would not be the most complex America's Cup 5-axis machined foil shape. These are pretty proven in terms of heave stability foil sections. So that would be a simple aluminum build. Okay, question from Kevin, and JB, jump in here at any time, please. Kevin asked, if the foil shear pin does its job, is there any remediation needed in terms of impact on the hull? Is the replacement of the shear pin system contemplated as a long downtime event? And how well is the vessel expected to perform without the foil in terms of max speed and range? Okay, excellent questions. So the replacement of the foil shear pin is meant to be a very simple exercise. So you have to reload the system in terms of pulling the foil back forward. So there is you have to crank that on, whether it be through a simple winching mechanism, but you have to reload the tension into the system, and then you drop a new pin in. I envision that if this all lives within the salon table, there's a nice little rack there that has spare shear pins. Cost of the shear pins is not expensive for each use. It's not deemed a long downturn event at all. In fact, it's a recover within minutes after the car crash, for lack of a better terminology. So you get clear of the object that you hit, take stock of the vessel, and then reload the tension into the system, put the shear pin back in. How well is the vessel expected to perform without the shear pin? And this is important because the hull form is designed to work without the foil. So there is, you kind of go left or right when you're designing a foil boat. One strategy is you commit that it's a foiling boat, and so this is going to be a foiling hull form, and it's going to have. I mean, you may have seen things like the Mocha boats that are currently going around the world in the Volvo Ocean Race, or what they now call just the Ocean Race. Those have like scow bows, very blunt noses to them, a lot of reserve buoyancy for, in the front of the boat. And those are basically fully foiling boats now. They're like at 90% lift fraction. So when they drop off a wave or drop off the foil, they're designed to, recover from those types of events. Now they're painful getting up onto foil. So their light air performance is really tough because they're carrying all this reserve buoyancy and stuff like that. So the power catamarans, the analogy continues where if you were just doing a fully foiling power cat, you would give it kind of a blunt nose like that, a lot of buoyancy in the bow. The Hope 40 is not that. The Hope 40 is a great power catamaran that benefits from a foil. So you could run it all day, every day. Some owners may even run this boat without a foil at all, and it would perform great like that in semi-displacement mode. It is less fuel burn, higher efficiency, of course, with the foil in. And almost, I would say more importantly, the ride comfort, particularly with a foil control system that varies the angle of attack of the foil, the ride comfort is going to be much better with the foil than without. And, I didn't really touch on the control system that basically uses a gyro compass and some sensors to figure out what the attitude of the boat is and adjust a combination of the foil angle of attack and perhaps some interceptors on the transom to keep the boat as locked in, as stable as possible. So if you have a significant other that gets seasick and doesn't enjoy, blasting out to islands offshore, then this is the boat for that person. That's the intent, is to really make this a sea kind boat, the kind of boat where you look at you see the weather has a small craft advisor, and you're like, I could probably still go and nobody's going to be throwing up or unhappy. So that's really, the foil system is centered on comfort even more than performance. That's its primary benefit. Okay, Kevin, hopefully I answered your questions.
Just to jump into, I would say that the shear pin, I kind of envision replacement time would very much like I was delivering a boat offshore a year or so ago and had a Celette drive, which is a English-built drive system, and it had a shear pin just like we're describing here. And after the Dolphin hit the propeller, or we hit the Dolphin, whichever way you want to look at it, it sheared the pin. And I think by the time we took, as David said, you assess everything that's going on in the boat and then figure out what happened. And I think it probably took us an hour to change the pin offshore in fairly windy conditions. So I would expect it to be much faster than that, even than that with more stable boat.
Yeah, our attitude about the shear pin and this whole system is it's not if, it's when, right? And that's where I can't wrap my head around these existing fixed foil systems, because when I hit that kelp off the West Coast, it's like that happens. You have to count on that happening. There's enough debris out in the ocean, whether it be organic or man-made, that to drag a foil around and not anticipate an impact, to me doesn't seem realistic. The other thing about the foil is you can retract it at any time. So basically, if you're pulling into Belfast or Kennebunk or somewhere where there's going to be a lot of lobster pots and it's a hazard to have something between your hulls, then you go ahead and move your linear actuator all the way forward. The shear pin, the tension on the shear pin goes slack. You remove the tension out of the system, and then the bungee retracts it in a controlled way. So you can get that foil out of the way if you anticipate you're going into a difficult navigate region. How many boats do you anticipate to be able to pull out of the tooling that has been quoted? Symmetric said that we were comfortably at 6. JB, correct me if I'm wrong, but we think if we take care of the tooling.
It's all about the care and feeding of anything, right? So
yeah.
The tooling, if taken care of, I've pulled many parts out of Symmetric's molds, and I don't see why you couldn't get really 15 to 20 parts out of it without much trouble. Again, you can't leave the molds outside for long periods of time. They have to be weather protected, but that's really their limitation. The reason you go to production tooling eventually is because eventually the heat of the infusions does affect the surface of the mold, but that can be controlled if you do your infusions correctly.
And the infusion's the preferred route, not only in terms of working conditions, but from the design office side, we see it really as quality control and risk mitigation. Again, is the infusion allows everything to be laid out dry, and it removes a lot of human error out of the process. So it's one of those nice when the stars align. That's the preferred method from the boat builder side, and from the design side, it's also the preferred method. Okay, then Matt asked also what level of outfitting is included in the base boat, navigation, electronics, textiles. I guess the best answer to that at this point, Matt, and again, we don't have a full specification document at this point, but it's boat as pictured, right? Like it's that boat is based, or that pricing is based on a lot of the renderings that have been produced in terms of fit and finish and electronics. It's kind of what you would expect, but it doesn't necessarily include like a full solar array. And you can take these things far. And JB could comment on this. I mean, you can go with exotic leathers, and the limit of money that could be spent on a vessel like this is high.
You can go into lithium ion and batteries, solar charging, all that kind of stuff, and that's not part of the initial basic package. Right.
Yeah, we're reviewing this again, and another way to answer your question is look at it from the usage standpoint, right? So this is a weekender, maybe a week with the family if they really like each other. Intercoastal waterway work. This isn't a retired couple living on this boat full time. That's not the mission for this particular vessel. Okay. Then Greg asked, how is 3-4 piece hull joint? Okay, very good question as we're dealing with this in modules. So those are seams. Those are composite seams, carefully engineered composite seams. So each of the pieces has a rebate in it that allows for taping, composite taping of the two panels together. Something that, from an engineering standpoint, we're very comfortable with. There is a slight weight gain at each of those seams, but again, the weight burn is worth the efficiency gain, if that makes sense. So we're looking at how do we produce this boat at a high quality level quickly, and this multi-mold approach seems to offer not only single boat efficiency, but multiple boat efficiency. So you can imagine that if you had 2 or 3 sleds of that sled mold lined up with the internal bulkheads in it, those could be being dressed out in terms of systems, which require a lot of labor and careful work at the same time. So you start to get into more assembly line production and multiple tracks with that type of tooling. So Kevin said, thanks for answering. And the control system, which I was going to ask about, sounds like you thought through the maintenance process. Nice. One question, what is the draft with and without the foil deployed? I actually don't have off the top of my head. Let me look real quick. Why I'm looking up that number, why I'm looking up that number for you, Kevin. I'll talk a little bit more about the control system because the computer geek in me likes to geek out on that kind of stuff. So what I learned from the America's Cup is that the control systems, particularly on the fully foiling side of things, they've reached into the machine learning side of things. So we're now using the buzzword of artificial intelligence, where these systems learn. They'll say, okay, on this given day, I'm experiencing this vertical acceleration at this interval. And so it's anticipating waveforms and adjusting according to the conditions it sees that day. We're not going there. We don't need to go that fancy with a 50% lift fraction foil assisted type of control system. So the control system that we're envisioning for the Hope 40 is what they call PID controllers. And these are tried and true robotics controllers that are used in a lot of heavy industry. So think very robust system, full of manual overrides that could come in handy. If you're in a long period swell and you're overtaking a wave and you want to induce a bow up attitude with that main foil, then there will be a dial to do just that. So you can disengage the auto trim on that main foil and induce a bow up attitude. If you do have somebody that is turning green on board, you can do this thing where you kick up the trim of your outboards and then push the foil into, the foil is trying to push the bow up, the trim of the outboards is trying to tuck in under the boat. And so there's opposing vectors there and the boat can really lock in. It's not the most efficient way to travel, but boy, it's almost like heaving to. It's remarkable, how it can stabilize the vessel. So that, I talk about automated control systems, but humans are still in control. This is not Skynet on the Hope 40 yet. The draft of just the hulls is about 2 feet, to answer your question, Kevin. And I'd like to sink the foils incrementally below that. So I would safely say we would be within the 2.5 foot draft with foils down. But again, if you are going shallow draft, if you're hopping over a sandbar in the Bahamas, you can pull that foil up. Would the foam in the bang plate area need to be replaced during a haul out after shipping? Yeah, I think that would be, again, we have to fully design that system, but I almost see that as a styrofoam, not a expensive piece of kit, but it allows it to, because the trailing edge of the foil that's finding its way up into that bang plate, that's the most fragile piece of the foil. So rather than making the foil overly tough, to replace the inexpensive styrofoam within that bang plate region seems like a reasonable approach. It involves you hopping in a dinghy and going underneath, between the holes underneath the boat. But we would anticipate that being a serviceable item. Okay, I think. Oh, what do you? Matt just asked another question. This is good. Please keep the questions coming. We're at 5:10 now, so we're doing pretty good on time. Envision Composites E-glass carbon. So it would be E-glass, monolithic with some foam. Corcel M foam would be the preferred, and then maybe some localized carbon on stringers and on primary structural members. And it's very easy to justify the carbon in those locations because the additional material cost will save you on the labor cost, because it's just less plies that have to go down. So it's not using carbon for carbon's sake or marketing purposes. It's really a strategic use of carbon. But overall, this is an E-glass boat. Resin type, it's kind of a variable market for resins these days between epoxies and vinyl esters. So too early to call that. Okay. Any other questions? Feel free to use the raise hand functionality if you'd rather do that. This Zoom call is going to be posted up on the Front Street website, so feel free to play it back if you didn't catch anything. And then, of course, we are available for follow-up questions.
Yep.
My email is very simple, david@mcculloughyachts.com, and JB is not hard to find.
Mine's very easy. It's JB at Front Street Shipyard. So
yeah, I wasn't.
Take a lot of imagination for either one of those.
Yeah.
But yeah, thank you all for all your fantastic questions, and for David's for the great explanation of how everything is put together from both a technical standpoint and just the basic boat building side.
Great. Okay. Looks like no further questions, so we'll go ahead and wrap it up there. Thank you very much, everybody.
Thank you.